Welcome to another edition of 3D Printing News Unpeeled, live with yours Peels. And today we're going to be discussing a couple of new 3D printing and additive manufacturing news items for the day. And we're going to start off with Divide by Zero launching a large format 3D printer. So Divide by Zero, also called DBZ, is an Indian technology company, and they've just made a printer that is called the Aeon NX, which is targeted at the pattern mold making industry and large industrial companies for applications such as tooling, composites, tooling, molds, and just generally large parts. And when we say large parts, this printer is capable of making 1 meter large components, 1 by 1 meter large components, which is quite considerable. And it uses granular extrusion, which of course means that they cut considerable costs. On top of that, you can switch out the extrusion system and put in like a paste or a gel or even a ceramic extruder to get some different types of materials. So it seems like a very versatile 3D printer. And it's notable for another, made in India kind of 3D printing success again. We're seeing more and more things happening in India, and this is very good at they're also making their own equipment as well. So that's number 5 news item. The number 4 news item is 3D Systems spins off its bioprinting startup into, or its bioprinting business into Systemic Bio. So 3D Systems acquired a lot of medical 3D printing kind of assets, including Levy, Volumetric, Camovis, and others. And right now, it's putting most of the bioprinting assets into one business and spinning it out. Um, it's giving this business 15 million in cash to go with it, and hopes it fares better than inside of 3D Systems. So this is another one of these things. Is a little bit of a head scratcher because you don't know what it is. Tacey Pereira is going to head it. She was formerly the CSO, the Chief Scientific Officer of Levy, which is another company that 3D Systems acquired. And it either okay. So on the one hand, in the long run, bioprinting is an incredibly exciting thing. It's a thing that's sure to really grab investors' attention, be sure to be very hyped. And what I assumed was 3D Systems' strategy was to bet on medical for the medium term, let's say, and have long-term success in bioprinting, and have that kind of warm glow of the expected success of bioprinting to wash over 3D Systems stock until then. By bundling the bioprinting assets into a separate thing, the company's actually going to do something else. It apparently thinks that the capital can be better deployed in a kind of spin out type of business, maybe better get a lot of investment that way, and well, maybe it said, well, if it doesn't bring us earnings right now, maybe it's not that interesting, or maybe the risk of this and the risk kind of attached to it, kind of the hit and miss potential here, is just not some kind of risk that the 3 Systems as a corporation wants to carry. So it's a bit of a puzzling thing. I would think that it's worth it. I mean, some of the things, for example, are very investable. I think they've got this for right now and could generate quite near term thing. The thing you're seeing in the picture is HVIOS. It's a human vascularized organ system. It's like a organ on a chip. And this system, you hook it up to all sorts of medicines or new substances you want to test. And the idea is you can test this in a much more accurate, much cheaper, much faster way than if you're doing this with animal testing or with other kind of simulations of what an organ would be like. That to me seems like an eminently commercializable thing in the relative near term, like compared to like 3D printing lungs and all the other stuff we saw on 3D Systems talk about previously. So I'm not sure about this. I don't know. I think 3D Systems has been doing a lot of really great work in making a turnaround and really making it a much more interesting, much more cohesive company with a cohesive future. And this is one that's a bit of a head scratcher. I don't know. I don't know if it's a good move or not. We'll have to see. The number 3 point of news is machine learning for better parts. This is news that Orion AM, which is a German Berlin-based manufacturer of high-temperature material extrusion system 3D printers, has worked together with Exponential Technologies using the data science platform XTSAM or XTSAAM that Exponential Technologies has. What that is like a machine learning kind of data science type of platform. And the idea is that you can accelerate your learning processes You plug in lots and lots of data. It can help you get to new realizations faster. And what they did is they tried to get better mechanical properties through varying settings. Now, this is, of course, everybody who operates a material extrusion printer at home, we've all done this. And we kind of tend to, as human beings, do it in a really kind of very random kind of way. And we also know that there's all sorts of feedback loops and things interacting between these settings. So it can be actually quite complicated. So what the team did is they used the Orion AM's new A150 printer, which is actually a material extrusion printer that additionally can heat the material significantly. So thermally heats the material, reducing the material gradient, or the temperature kind of shock that the material has to go through. And by directly heating the material, rather than what it can also heat the build platform and the surrounding air, of course, but by directly heating the material, they can heat individual layers and get better layer adhesion, and that's always been their kind of claim. Now, this a little bit of work goes to kind of support that claim, because what they did is they said, okay, let's vary infill temperature, layer temperature, fan speed, bed temperature, and infill, right? And layer temperature is, of course, something that they're kind of more better able to control than other people. And let's do that with two different peak materials, one from Solva and the other one from Evonik. And let's try to get better results. And they did get better results. So the key thing that they got is that they exceeded in tensile strength and elastic modulus the results you'd normally expect to get from injection molding, which is a considerable result, actually. It's a result a lot of people have been chasing for a lot of different applications, a lot of different times. The company said that they had the peak, the injection molded peak is about a tensile of 90 MPa. Elastic modulus is about 3.3 gigapascal GPa. And Orion was able to get a 95 MPa in tensile, a 3.8 GPa in tensile modulus for the Solvay filament, and a 92.8 MPa and a 3.7 GP for the Evonik filament. This is a great result. I mean, it exceeded injection molding. Now, of course, you have to independently verify this and all this kind of stuff. But let's just think about this for a moment. Let's just think of, well, one thing, it's great for Orion, this news, that they can come out with this and say, hey, look, here's the data. This is what we did. I think, as a marketing thing, this is a wonderful thing to be doing, because it really makes me look very serious at the company. And then on top of that, this platform, the SAM XT platform, sounds like it could really accelerate a lot of people's work. And it could really, like, a lot of people spend an awful lot of time on the material companies, on application companies, on services, on trying to dial in settings. And if they just had a platform specifically to dial in settings in a more rapid way, in a more systematic way, this could be a huge time saver for our industry. And I hope that in the future we'll see many more tools doing this. And imagine, by the way, if you did just a number of experiments, a number of parts you printed, and you fed the data back into a platform, and then it, for example, told you the optimal settings, but also the optimal settings for like 100 different other printers, right? Or at least inferred ones or close ones. I mean, that would save a lot of people like a ridiculous amount of time. And then, in material extrusion, it's kind of ridiculous to say, like, hey, the temperature is like around 400 to 420 C or something like that. It's kind of crazy. So this really caught my attention. I hope we see a lot more news like this. The next news item is in advanced science. It's from the University of Minnesota Twin Cities. They've got a 3D printing light sensing medical device, which is placed directly on the skin. Oh, I forgot, by the way, to advance the picture thing. This is the Orion printer, by the way, and this is the low light picture, apologies for that, of this light sensitive monitor system. The idea is that it senses light, it's wearable on the body, and it gives feedback on the light intensity. Now, why do we care about this? Now, we care about this because there's certain diseases, one of which is lupus, that are adversely kind of influenced by light, right? There's also kind of people that have like kind of sunlight allergy, kind of more things, or just any kind of skin type of thing that can be adversely affected by light. You can have kind of like a flare-up of your disease if you're exposed to light. Now, the idea is that this sensor system is going to be worn by people, and then you'll be able to see when you flare up in response to what light, or maybe for you, the sunlight isn't a bigger problem with your lupus, but somebody else's like really completely needs to stay out of the sunlight all the time or something like that. So for light sensitive diseases, by the way, there's 5 million estimated lupus sufferers worldwide. So for light sensitive diseases, this will get real-time information back to a clinical setting where they can maybe monitor your individual progress to the light sensitive nature. Now, what they did is they made a flexible UV visible light detector. They had 3D print. Well, they had a silicone base. It's unclear if they printed that or not. But then they printed materials on top of that, including the electrodes and the filters themselves. So to me, I would really expect, like, not hope or not think, but I expect there to be many more devices like this, many more devices that are feeding, particular sensor kind of devices that are feeding lots of information. And the idea is, of course, to make these things compact and conformal and comfortable to wear people all day, and imagine type of all sorts of devices, not only for light, but for all sorts of conditions, and also measuring all sorts of things. So I think this is a really great thing. The team even says they hope in the future they could print these items in the office. I don't know what the logic is for that, but still, that could be very exciting to 3D print something in the office that would have, be particularly comfortable for a particular patient, or maybe you swim a lot, so you need like a different version. But I only go in the shower like once a day or whatever, and then so I can have a different version, something like that. So to me, this points to a whole new class of devices, medical monitoring devices that are made with 3D printing to be more compact and more wearable. The number one news is is a paper by Eetu Huttunen and other people. Eetu is from the Southern Eastern Finland University of Applied Sciences, and these researchers have looked at Ice9. Ice9 is a filament from TC Poly. TC Poly is a very high-tech startup, very great company making thermally conductive, and so non-electric. Well, they do have a bunch of different cutting-edge materials, but they have, for example, a thermally conductive, totally not electrically conductive filament, and this is called Ice9. It's a PA 12 material with some super special materials in it. Well, the idea was what Ice9 told everybody in the beginning is we could make polymer heat sinks. This seemed like a very exotic idea. It seemed like something that was maybe great for some defense applications, but why would the rest of the world care? Well, we would care because there's a continued miniaturization of electronics. We want to make a lot of things lighter. We want to make a lot of things cheaper as well. And we want to put more and more antenna, more and more sensors, more and more all sorts of stuff into our mobile phones and Fitbits and all sorts of things. So to make a conformal heatsink that is also maybe, for example, a fastener, right, that holds in place a chip, whatever, but that also maybe is a fastener, holds in place a chip, and is a heatsink, would really save a lot of space on the form factor and also make that wash thing a lot lighter. So this is potentially, and think about it, we don't have to solve all the heatsink problems because there's well, depends if you count MOSFETs and stuff, but there's millions or billions of heatsinks, right, in the world, or many billions, right? It's one of the most made things in the world. So we only have to take a really small percentage. So imagine if only like one kind of health monitoring device maker turned to this solution to make a better heatsink for its particular device. That would already mean there are hundreds of thousands or maybe millions of devices that would use this technology. So that would be a big win for TC Poly. Now, anyway, so what the team have done now is use a Mini Factory Ultra machine to essentially look at the performance of this thermally conductive Ice9 filament. What they concluded is that it can be compared to aluminum. And that's a very good kind of result. And that means that maybe in certain cases, it could be lighter or more cost effective or better to use this thing. And especially if we're looking at, they compared it to the performance of conventional finned kind of heat sinks, and it seemed to perform better than that as well. So I think these are one of these advancements where you're thinking, well, nobody's doing this. It's only this one company, TC Poly, that's doing this. Why is this interesting? Well, it could be interesting to just one design group, engineering group at one, like Apple or Samsung or whatever, and then already the impact of this would be immense. So this is the news for today. I hope you enjoyed it and have a great day. and